Greetings, everyone. Hello to our participants and attendees from around the world, and welcome to the second GEO Knowledge Hub Knowledge Package Deep Dive. The first one on the Knowledge Hub was on the 24th of February, and the second one is looking at land use land cover classification and the knowledge package concept, which has been worked on by the Brazilian DataCube team at INPE. Just as a recap, the GEO Knowledge Hub is a cloud-based digital library or repository that provides access to knowledge required to reuse applications of Earth observations. The purpose of the Knowledge Hub is to reveal all components of a given application using Earth observation data, whether it's stored in the Knowledge Hub or in other repositories. So this session today is on for 1 hour. And we have a number of speakers from INPE, the National Institute for Space Research, who will be taking us through some of their experiences. So first up, I would like to introduce my colleague, Paula De Salvo, who will introduce the objectives of the webinar for today. Paula.
Thank you very much, Stephen, and indeed welcome to everyone for this second webinar on the GEO Knowledge Hub. We have been working in close collaboration with the INPE Land Use Land Cover team, and the objective of today's webinar are really to show the experience of a knowledge provider in preparation of all the elements needed to create a knowledge package from an Earth observation application. And in this case, it's the land use land cover classification prepared by our INPE colleagues. The second objective is to show in the steps needed to go from a research to a full reproducible Earth observation application. And furthermore, highlighting the benefits for both the institution, and so in this case, INPE, and the end user in fostering open knowledge and science and Earth observation application. So we wish you good listening, and back to you, Stephen. Thank you very much.
Thank you, Paula. So our first speaker is Dr. Karina Ferreira. Karina is Professor of the Applied Computing Graduate Course at INPE, and she's one of the coordinators of the Brazil DataCube project. So she's leading research and development in big Earth observation satellite images processing. So Karina is going to talk about the relevance of the Knowledge Hub to the Brazil DataCube. Over to you, Karina.
Oi. Thank you, Steve. First of all, I'd like to thank GEO for the invitation. And it's a pleasure to talk about these interesting things here. So in the Brazil DataCube project, we are investigating different methodologies or techniques to create temporal composite data cubes and to produce land use and cover information from these data cubes. So we are testing different machine learning methods using time series of distinct spectral bands and indices with distinct sets of training samples for specific regions here in Brazil. And besides that, we have researchers, PhD and master students investigating these methodologies and techniques and publishing papers about the results of these investigations. So for us here, in the context of the Brazil DataCube project, the Knowledge Hub platform is very useful to organize all these resources or pieces related to these investigations, samples, data sets, papers, code scripts, and so on. So we can, using the GEO Knowledge Hub platform, you can organize all these things in a such way that we can easily reproduce these investigations. We can share these results with other students and researchers that work in the same subjects. and we can easily collaborate with other groups of researchers. So for us here in the context of the Brazil DataCube project, the Knowledgehub platform is very important for us to concretely implement open science practices. So that is.
Okay, thank you, Karina. So next we are going to move to Lubia Viñas, Dr. Lubia Viñas. Lubia has been a researcher at INPE since 1997, and she's currently collaborating with the Programme for Satellite Monitoring of the Brazilian Amazon and the Brazil DataCube as well. She's leading the design of INPE's new georeference database program. So over to you, Lubia.
Hi, Stephen. Hello, everyone. Good to be here. I would like to thank you, GEO, and the organizers of this webinar for the kind invitation to speak a little bit about open science from INPE's point of view here today. Hello?
We can still hear you.
Ah, okay. All right. I thought that you were going to ask me something. But I think that INPE has been, along the years, has several initiatives related to open science. We were one of the first agencies to adopt an open policy for remote sensing our CBERS data, for example. We also provided a complete GIS, a full general purpose GIS called Spring for the Brazilian community as an open and free technology. We also have a digital repository of all the dissertations and papers that are being developed at INPE. So I think that we have been committed to this basis of open science, and since at least 3 decades in a very pragmatically way. And now I think that with the GEO Knowledge Hub, we are creating another layer on top of these basic fundamental initiatives, because it's supposed to link all these resources for specific results, and it will in a way that it captures knowledge, because you could have the data free, you could have the methodology described in a paper, and but with the Knowledge Hub, you in a way link all these resources, providing encapsulating the knowledge, the complete knowledge about one particular result. And I think that this is very interesting and very useful for not only the INPE community and the Brazilian community, but also for the international Earth observation community. That's why I'm very supportive of this initiative. In another way that I see that's a benefit for us is because we have the opportunity to work in the development of this platform with people from GEO, from other organizations, and then we can also be better at working with open science and open knowledge.
Thank you. So you talked about encapsulating knowledge in a result. Can you just explain INPE's commitment to open knowledge and open science?
Well, as I said before, I think that we are very committed, at least our area in Earth observation, we are committed to open science for a long time. I mean, we have been working with free and open source software for GIS for such a long time, and we are moving from we are following the state of the art in the technology. So as I said, we start with a general purpose GIS based on dual architecture, and then we move to the geographical databases and have the use of spatial databases, and now we are working with data cubes. So I think that along this way we have been worried about having these products as a free technology for everyone. And in the data is the same. I mentioned the imagery, but I can also mention the results of long-term projects, such as the projects for monitoring the vegetation, the forest cover in Amazonia. All the data is public, is available on the internet. The images, the results, the analytics over the images, and so I think that, in my opinion, we are very committed to open science in a very pragmatical way. We are exercising this through our results and our projects and our data, and I hope that this direction continues forever.
So thank you, Lubia. That's like your open journey.
Yes, an open journey.
In terms of the where you are on your journey, how do you describe the value that is added by the GEO Knowledgehub for INPE?
I think that it's an opportunity to go through reproducibility in an organized way. Although we have the results opened and the technology opened and the data is free, but maybe it's not so easy to reproduce it because the methodology might be a bit complex. Along the way, we have made decisions about the data, and we have a specific goal in mind that maybe it's not completely captured just by leaving the pieces of open data technology and free. The Open Knowledge Hub, I think that for us is a way to move towards the reproducibility of our results. And this is very important for us too, because it adds trust to our results. It adds a possibility to improve collaboration with other people and other organizations. So I can see added value to the GEO Knowledge Hub.
Fantastic. Thank you very much for that. So
Thank
for
you.
those of you who have joined us slightly late, we've probably doubled the number of participants in the last couple of minutes. I just want to remind you, this is the second session of the GEO Knowledgehub webinars. The last one was on 24th of February. And this one is what we're calling a deep dive into knowledge packages. And we're doing it with the National Institute for Space Research, INPE, in Brazil, and looking at the work they've done with the Brazil Data Cube. So we've had Karina Ferreira and Lubia Vinhas, who've just presented. And now I'd like to introduce our speaker, who is Dr. Gilberto Queiroz. And Gilberto is a senior technologist at INPE. He works in research and development projects related to the geotechnologies that support the activities for monitoring the Amazon and other Brazilian biomes. And he, for 5 years, since 2016, has been an associate professor of geoinformatics and geospatial data science at INPE. He is also one of the Brazil Data Cube project leaders. Over to you. And I should say he's going to talk about this deep dive into land use, land cover classification, the knowledge package itself. Gilberto.
Hello. Welcome to the second webinar dedicated to the GEO Knowledge Hub. Following the introductory words from my colleagues, Doug, Lubia, and Karine, I will illustrate you the path as knowledge provider that we have been following to enable the Brazil Data Cube application to be open knowledge and its inclusion in the GEO Knowledge Hub. INPE has a long tradition on researches related to creation of land use and land cover maps, mainly in the Amazon and Cerrado biomes. These are some of the consolidated projects which are carried out by INPE, often in collaboration with other institutions. PRODES has carried out the inventory of our clear-cut deforestation in the natural vegetation that has occurred in the Brazilian legal Amazon since 1988. The DETER system generates deforestation alerts based on the analysis of daily images from the CIBER satellite series. And the Terra class identify what the deforested areas detected by PRODES become. So our team at INPE has been working on research and development of methodologies and technologies to support these activities. This picture summarizes the methodology behind our work in the Brazil DataCube project regarding the creation of land use and land cover maps dealing with Earth observation data and machine learning techniques. So, we start from the Earth observation data cubes. They are temporal composites created by a best pixel algorithm. We use land use and land cover samples obtained by specialists using high-resolution images. So, from the data cubes, we extract the time series for each pixel associated to the samples. These time series are then used to training a machine learning model. In this particular case of this application, we use a multi-layer perceptron neural network. Once the model is trained, it is possible to classify the entire region being mapped. The output of the classifier are the probabilities of a given pixel to belong to each of the sample's classes. With this probability raster, we apply a spatial smoothing model that homogenizes the map areas using Bayesian inference from the information given by the neighborhood of each pixel. So, and finally, the land use map is obtained by taking the most likely class. Therefore, the knowledge we want to share is the methodology we are developing. So our presentation will focus on how the various components related to this research pipeline are turned into resources in the GEO Knowledge Hub. In the GEO Knowledge Hub, all the components of an Earth observation application are represented by a knowledge package. The knowledge package contains all the essential elements of the application necessary to its reproducibility or replicability. In the case of our application, it has a knowledge base centered on some recent papers published by the team. And in this slide, we highlight the components of the application, which were documented and structured in the GEO Knowledge Hub as a knowledge package. It's worth mentioning that we are not only reproducing a specific article, we created an application based on the methodology and technologies we have been developing. So, in addition to sharing the data and the code, we wrote also some documents to help users understand each of the resources. These are documents that complement the scientific publications behind the application. Therefore, we created a short document explaining how the user could access the data cubes in the Brazil DataCube platform as used in the application, a document detailing the samples, their classes, the data structure used to organize them, Another document that informs where are the maps that materialize the result of the application and the interpretation of the values of these data sets. Another document on the organization of the R scripts. In the case of users who will use the Brazil DataCube platform, we described how they can enter in a sandbox with a set of Jupyter notebooks ready to be used, with all the computational environment and auxiliary data already prepared. An equivalent document for a version with the RStudio integrated development environment. A document indicating how the user could build his own compute environment and use the application's script. And finally, a document explaining the application in general terms, our step-by-step guide for the application. So I'm going to start with the publications that are the basis of this application. There is a central paper with the methodology and technologies we used, one with the methods we use to evaluate and identify spatial-temporal patterns in the samples, and another one that could serve as a source of inspiration to the use of different machine learning algorithms and some variations in the methodology. The study area is located in the Cerrado biome in Brazil, in the northeast of the country. In the resource that describes the data cubes used by the application, the user will have a guide on how to access the data cubes. It explains how they are generated, what are their spatial and temporal coverage. For example, we use data cubes from CBERS 4, Landsat 8, and Sentinel-2, based on a 16-day temporal composite. We indicate the portal where they can obtain this information and the address of the stack services that the user can use to access the data cubes. The training and validation samples are also explained in detail. The metadata and auxiliary documentation in the Knowledgehub contains an in-depth description of the sample set used for training the multi-layer perceptron model used in the application. So we provide the data in many formats, in the CSV and the Esri shapefile formats as shown here. The training samples contain almost 1,000 data points organized in 3 classes: crop, natural vegetation, and pasture. They were collected by visual interpretation of high-resolution images. And in the same way, we have a resource with information about the sample set used to validate the classified maps. So this data is based on the project Cerrado. To make things easier for the user, we provide the samples in the format used by the software stack used by the application. So besides the Esri shapefile, there are RDS files that include the time series related to each sample and for each pair of satellite sensor. So we have the spectral temporal signature related to the samples. And this is what will be used to train the machine learning model. The code shared is based on a set of R scripts. We use an open source license for these scripts. To make it easier for the user, we created a version using the Jupyter Notebook technology with a fair computational narrative of the application. We also built a version using R Markdown with the same computational narrative for those that prefer the RStudio environment. And the main technology behind the creation of the maps is an open source R package named SITS. We also described how the user can have a computational environment based on it. So the SITS package is designed to work with satellite image time series and to support most of the steps of the land use and land cover classification workflow, including sample evaluation, machine learning classification, and map post-processing. This package brings together a set of tools for time series analysis and visualization, such as self-organized map clustering and time series filtering. We have prepared some resources with a specific version of the SITS package and all the libraries needed to run the scripts or the Jupyter notebooks or the R Markdown. There are also instructions on how to use Docker images to prepare the environment on-premises hardware and how to access everything from the web. The last resource developed describes the set of thematic maps that are output of the application. As I mentioned in the beginning of the presentation, the classification output of the multi-layer perceptron model used in this application is a raster with one layer for each land use class. These layers contain the probabilities of each pixel belong to each of the classes. So we also shared the GeoTIFF files with these probabilities besides the thematic maps and a document with an in-depth description of these files. The digital library of the GEO Knowledgehub is the place for the users to discover the Brazil DataCube application package and all its essential related resources. So let's get into the prototype of the GEO Knowledgehub digital library to see how we shared some of the components of our application. So a user looking for land use and land cover applications will find the package with the Brazil DataCube. So here is the knowledge package. From this package, we will have all the information of its components. Currently, the digital library does not yet deal with all the elements in an aggregated way, but it is already possible to locate the individual resources. So here in the main package of the application, we will find the metadata of authorship, the contact information, a description of the application, and the document that contains a step-by-step of the available components. So this document here explains in detail how the user can start working with it. So here we have the list of all the resources related to that application. In this lower part here, right now, we have only a list of linked resources, but in the future, we will have the components properly presented and ready for more detailed inspection, as we saw in the last presentation of the Knowledgehub. If we go to a specific component, such as the samples, let's get the samples here. We will find the training and validation data sets in various formats. So here we have them in Esri shapefile format, the RDS, and the CSV. And also a guide that explains the structure and the fields of each of these files. We can, for instance, preview the CSV file here. And in the long run, we hope that users could, for instance, access a sandbox with everything prepared on it. So let's come back here to the resources and come to the software environment and select here the Jupyter Lab sandbox. So this sandbox here contains a detailed guide on how we have deployed the Jupyter Hub on our platform at INPE with a restricted access right now, but this could be one way to allow lowering the barriers for the reproducibility of this application. So if the user goes to this guide here, it will have the information to arrive into the sandbox. So as soon as the user sign in into the sandbox, it can start the computational environment based on our software with all the libraries already installed. And then the user can browse the material of the application here on the left panel here. So they will find all the Jupyter notebooks related to that application in a way that the user can work with can learn with the annotations and with the code. So this is a cell code that produces this simple map here. And displays the samples that are going to be used for training the classification. So all the Jupyter notebooks will be available for the user in this environment since the extraction of the time series with information about the crop calendar, the sample data points, how they will extract the time series from a Cerebras data cube or a Landsat 8 or a Sentinel-2 data cube. Then for each data cube, there is a specific guide that covers the classification process again. So just to wrap up the presentation, INPE has a long tradition with open data and with free and open source software. This knowledge package is a start point for our team regarding the open science and reproducible research practices. So we are learning in the way also. We have many things that we can improve to share this application. The extra work realized in close collaboration with the GEO Knowledgehub team also helped us to shape the communication of this application. We had many insights preparing this specific application in the GEO Knowledgehub. The steps required to become a knowledge provider probably will be made easier as more people join the initiative and the practices are fine-tuned by more people. We still have a lot to learn in this road of reproducibility, but it opens the floor for more collaboration. The amount of investment in Earth observations applications calls for its reuse. And as my colleague Lubia said, decision makers need updated and trustable information. Science provides the methods and the technology to generate new knowledge. The scientific process can be very complex and dependent on different technologies and techniques. And the GEO Knowledgehub is a bridge that provides the essential information for decision makers linked to all the aspects of the scientific practices. So in the name of the Brazil DataCube team, I would like to thank the GEO Secretariat for the invitation to participate in this second webinar of the GEO Knowledgehub. Many thanks to all the Brazil DataCube team for their support on the preparation of this knowledge package. And finally, many thanks for your attention. Thank you.
Great. So we are now going to move to the Q&A session. And I want to give the first question, which has come in from Laurent Durieux, who is from IRD in France. And Laurent's moving to Geosecretariat quite soon to work with us on SDGs. Laurent has said that INPE's done a lot of work on deforestation monitoring in the Brazilian Amazon in a very open way, but it's not done at the same level in other Amazonian countries. Do you think the Knowledge Hub will help other countries to engage and complete the yearly deforestation map of the Amazon? Lubia, do you want to answer this one?
Yes, thank you, Stephen. Lohan, I think that our approach to other countries regarding forest monitoring is always first to respect their autonomy to develop their monitoring systems according to their context. We have been offering our experience in engaging in multiple capacity building activities. And I think that as we are moving towards more automatized procedures, having the mapping more automatic, and this capacity building and experience exchanging will be on this direction, to use these automatic methods to do the mapping. And to do that, I think that the Knowledge Hub is a very interesting tool for the other countries to experiment in a very practical way how we are doing that. So I would say that it will help other countries if they are, because they can try to do exactly the same as we are with the help of the Knowledge Hub. I don't know if it answers your question.
Thank you, Lubia. I think so. I mean, if people are unclear on answers, if they want a more complete answer, they can raise their hand and they can also speak, or they can come back into the Q&A. So we have a question from Bente B from Norway. And Bente has asked, how do we handle the use of scientific papers that are not open when that is, in fact, the basis of the work that's being done? So maybe I'll give this one to Gilberto Queiroz.
Hi, Stephen. Let me close the window. We have, in the beginning of the Knowledge Hub, discussed a lot about this. But now I'm saying as the GEO Knowledge Hub team. So we discussed about using the post-prints of some researches that are not published as open research, as a way to also to have the research also linked in the hub. So I don't know if Gilberto Câmara discussed a lot about this, and Doug also, if they want to.
So maybe I'll invite Doug Kripe, our senior scientific advisor. Doug, if you want to give some input.
Yeah, thanks, Stephen. The whole basis of the Knowledge Hub is open science, and the reason for that is because, as has been discussed in the previous webinar and then also reiterated today, the point is that these knowledge packages enable someone to reproduce what's been done in a first instance and then replicate it or generalize it to their particular area of the world. So the only way that can happen is if every component in the information chain in the knowledge package is open. So having open papers, open peer-reviewed articles is really a key component. And if that were not the case, that would be pretty difficult to build a knowledge package around that, at least as it now stands. I mean, the Knowledge Hub team would work with the publisher or the research group to see what they could do about getting a postprint that might be fully available. But really, the basis of the Knowledge Hub is open science across the board.
Thank you. Thanks, Doug. So the next question comes from Flavia Mendes, who is Brazilian in Europe. Flavia is asking, regarding land use mapping, which biome in Brazil is the most challenging? And since you have biomes in your title, Gilberto, maybe you want to answer this?
Steve, I think that Lubia or Karine could give a better answer, because okay. I'm not the specialist of the biomes. Please.
How about you, Karine?
Yes, because I agree with Gilberto, because we are, I don't know how to explain this. So I think Lubia can add something about this specific question about land use change in Brazil.
Okay, I'm not an expert also, but I can give you some hints, Flavia, about what I have about the information that I've been collecting from the experts. I think that the biomes are quite different. One of the biomes that are more challenging is Caatinga, because Caatinga, it's a very dry region, and people use the vegetation a lot for several uses, and they not only the climate that makes the forest, the vegetation there grows up and dries in a natural way, which is very hard to capture in the remote sensing data. People use the woods there for fire, for example, and then what I see is that it's very difficult to capture all these dynamics using only remote sensing data. If we look for the Atlantic forest, as it is a biome that has been changed a lot, and there are small patches of preserved areas, is also another difficulty, because you have to have high resolution to map these smaller patches of deforestation that happens there. So I think that each one of them has its own challenges and difficulties. I think that you are aware of that, because you have been working with that too, with SAR and everything. But I would dare to say, from what I hear from my colleagues, from Claudio and Danielle, our colleagues in the Amazon monitoring program and biomes program, that Caatinga is right now the more challenging biome to monitor. But if it's not right, please don't blame me. Because, as I said, I'm just collecting the information that I hear from the experts in forest and vegetation. Okay.
So look, we may come back to that topic. I want to move on. We now have Shamuel Houke. I'm not quite sure how to say it. Do you need any user ID or password for entering the Jupyter Knowledge Hub, as was shown in the presentation? So that's definitely to you, Gilberto Queiroz.
Yes, the sandbox that I showed here in the last part of the slide, as I said, it has a restricted access right now. So this is one of the reasons that we built some other possibilities to deploy the same environment outside our infrastructure right now. But we hope that in the longer run, we could have something more open to the collaborators and the network involved in the use of the GEO Knowledge Hub. I don't know if Karine or Lubia want to add something related to this.
Ladies, do you want to add anything? Karine or Lubia?
I don't have anything else to add. I think that Gilberto is correct.
Yes, I think Gilberto says everything.
Okay, Gilberto Camara, do you want to make an intervention?
Yes, please. Let me just be more general because of the attendees are really from different backgrounds. The crucial bit here is whether you have access to a cloud platform. And that's the crucial issue. Some cloud platforms are more, let's say, they have charges would go from one very small ones, in case of Amazon, to higher as you start. Some that Google has. But I think the important point that we would like to say that this development, and I'm going to put it on the chat, is non-biased. Well, it's something that does not work only on Brazil Data Cube. So what is going to be put on the Knowledge Hub is how the work was done, but in principle, the software that underpins this is completely open and works on Amazon, works on Digital Earth Africa, works, we work with Microsoft Azure, and obviously also works with the Brazil Data Cube. And therefore, it is, I mean, of course, there is currently, because the Brazil Data Cube is for Brazil, you may or may not be interested in working in Brazil because the data of Brazil Data Cube is only in Brazil. But if you have another area where you are interested, which is, if you have an area which is interested inside Brazil, I suggest you contact Karine and Gilberto directly to discuss whether you can use the Brazil Data Cube for data in Brazil. Now, if your area of interest is outside Brazil, then of course you want to use the tool to reproduce what was done in Brazil in your environment, Africa, Asia, or somewhere else. In this case, I suggest that you take a look at the two links that were put on the chat, because that's where the software and the documentation live. And of course, it's all open source. And what the effort that the Brazil Data Cube team is making is to make it available not only in the Brazil Data Cube, but on Amazon, on Microsoft, on Digital Earth Africa, on essentially any cube that has, technically speaking, a stack endpoint. So I hope that if you are now interested on using it somewhere else, you can also contact the Brazil Data Cube people, but not exactly to use the Brazil Data Cube, but to find out what the technology is all about. I hope the documentation, which Brazil Data Cube team has worked a long time, can put you forward. Thank you so much, Stephen.
Thank you, Gilberto. So just on the documentation, there's a question from our colleague, Brian Kilo at the NASA CEOS office. Brian has said there are 8 additional documents used to describe the submitted material. This is obviously a significant effort. Is the same level of effort expected for all submissions, and might this deter some users from submitting? Who would like to take that? Gilberto?
May I start, and then I pass the question to Doug and Paolo also, because this is very interesting, the discussion here. For us, for the Brazil Data Cube team, this S3 Fort, it was very interesting because it is very complementary with the work we are carrying out right now. So although it is an extra work, it's worth a lot to do this extra work. So this wasn't a problem for us. in the case of the other knowledge packages that we have been working in the GEO Knowledge Hub, so now I please Rick and Doug jump into the question, but they have different levels also of on the preparation of these materials. So the maturity of the work and everything related to the knowledge they are sharing in the Knowledge Hub. So this is also very different from each one. So there is not just one recipe that applies to all of the knowledge packages. So please, Doug or Paola.
Paola, please.
Thank you, Gilberto, and thank you, Stephen. Yes, exactly. To complement what Gilberto just mentioned, in order to write these step-by-step guides and more in-depth for each of the resources, producibility and replicability, and putting ourselves in the shoes of a given user and with the different competencies that a given user would have in fully understanding the various elements. And so, yes, indeed, it takes time from a knowledge provider point of view. And in this first case study, the GEO Secretariat have been supporting this brainstorming and creation of step-by-step documents. But at the end of the game, the end user will benefit of being brought by hand of the knowledge provider to full understand all the various elements in depth. So it is an investment that will pay over time for replicability of the knowledge. Back to you, Stephen. Thank you.
Thank you, Paola. I want to move on to another question from Kazuhito Ichi. And the question is, are all the data in the study stored in the Brazil data cube or stored across multiple servers? And then it says, do you assume to use external data sets not stored in specific servers? Gilberto Queiroz?
Yes. The data cubes are stored in the platform of the Brazil data cube. But the samples, the training samples and the validation samples, and even the final maps with the results and the probability, our intention is to deposit them in the Knowledge Hub as a trusted digital library for this kind of content related to Earth observation resources. Also.
Yes, I can add something, Stephen, if I can.
Please.
Yes, because in the Brazil Data Cube project, we are organizing these samples around the Brazil, land use and cover samples. So we have a database here with all the samples with metadata. And in this case, in this knowledge package that Gilberto prepared, he put a part of the samples in the package, but I think that these samples can be accessed through a web service or something through an API that can get the samples from other external data sets. So I think both implementation are possible with GEO Knowledge Hub platform.
Obrigado. So we have also related to samples, there's a question from Orestes Speyer, and it says, are there drawbacks from using interpretation of remote sensing data instead of in situ measurements? Who would like to respond? Karina?
Drawbacks from use, yes, there are in this project we are using a lot of samples that comes from visual interpretation of high resolution images, as well as samples collected in situ fields, work fields. Yes, there are drawbacks, but the Brazil is very huge, and we have to use different kinds of samples. Because of this, we are investing in methods to access and to evaluate the quality of these samples. So in the Brazil DataCube project, we are developing a set of methods using neural networks to help us to evaluate the samples, the quality of the samples. That is.
So Gilberto Camara, I think you want to make a quick intervention. We have 4 minutes left on the in situ topic.
I think the issue here is that what he's asking is comparing the results you get from sampling methods to results you get from computer processing and wall-to-wall methods. These are two different things. In sampling, you never, essentially the difference here is that the sampling methods do not cover the whole space. So you can get an estimate like you would do, for example, the same thing as you would do for a poll for a survey, but you don't cover the whole game. So you have an estimate of areas, but you don't know, you know the how much, but you don't know the where. So the how much is the sample can get, but the where you cannot get with sampling. That's
okay. Thank you, Gilberto. So look, we're coming to the last minutes, and Gilberto Queiroz, in his closing slides, he talked about the starting point for open science practice. He talked about collaboration tips, and he talked about reusable solutions. Gilberto, or Lubia or Karina, do you have any kind of final closing words on your experience of working with the GEO Knowledge package? Anything, any guidance you would give, like pragmatic advice for others who are interested in doing the same thing, or who are going down the same path? Gilberto, maybe you can go first.
Yes, I think that I'm very pragmatic and a technical guy. So I think that these practices are very good to be included in our research pipeline, and for us it will be very good to have a digital library where we can share the knowledge, and also where we can also learn from the others in the future about the same topics or the interested topics. Lubia.
Well, I have the only thing that I want to say is to congratulate you, Gilberto, because you are our you are working with this very closely, very hard, with close to the GEO, other GEO members, Paola and Doug and Rick. And I think that, first of all, I would like to congratulate you that being our representative from MIMPI in this initiative that I consider very promising and very interesting. I think that this incremental way that's being done, because you have now few packets, but you are proving the concept with these few knowledge packages and making the dissemination, having these webinars to engage more people to do the same. I think that this approach is also very productive, and I hope that more people will join the initiative, and I just want to congratulate you all for this.
Thank you, Lubia. So just in the final minute, there's a question about, would it be useful to share the land use land cover classification knowledge package with international organizations, for example, FAO, which is the Food and Agriculture Organization of the United Nations? The answer is yes, and we will be doing an outreach campaign, which will be international. We have more than 130 partners, which are called participating organizations, which include many of the UN agencies and these international bodies. So this will be something that we will do, and it will be happening from now and onwards. So thank you once again for, particularly to our colleagues from the National Institute for Space Research from INPE, and to my colleagues at the GEO Secretariat for helping to set this up. Please look out for the next session in the GEO Knowledge Hub webinar series. Obrigado, and have a fantastic day to everyone. Thank you.
Thank you.
Thank you. Thank you, everybody.
Bye.
Bye-bye. Thank you.